Hello, hello. Welcome to another stream where we'll work on Kast. Let's see. So last time we were trying to do the unwinding implemented in the C backend of the minicast, and off stream I did finish it and it actually works now. So here's what we have: the example where we do the raylib main loop, and we use unwinding to as a more general mechanism than just returning from functions, breaking and continuing the loops and everything, because all of those things are just unwinding. So in this specific example, I have extracted the main loop body into a function, and what we are able to do is we are able to unwind the main loop from inside of this function, right? Which makes it a non-local control flow. But yeah, that's what we want. So this works now in minicast while transpiling to C. Also, I've been improving on the generated C code a little bit, so it is a little bit looking cleaner, not as many parentheses, right? But yeah, basically now, after every function call, because we treat every function call as potentially wanting to unwind, right? Because this is similar to exceptions. So if we do want to unwind here, and then after every function call, we need to check, did we want to unwind, right? So this is basically an if error is not nil after every function call. Now, and now how specifically we unwind, it depends. So usually for the functions, you just like need to return from the function. If the function returns a value which is not a void, then we need to return some value. It doesn't matter what, something that is uninitialized is what we return in these cases. And if we are doing it in the unwindable block, right? So here's what we're doing. If it is the unwindable block, it starts over here, the unwindable block, right? So first we create the unwind token. And our main loop is basically the reference to this unwinding token. And then we are using a couple of go-tos. So here's the actual body of the unwindable, right? So it's like this code over here, right? We create the state and then we go into the loop calling the frame, right? So we create the state and then we go into the loop, calling the function. And since this function is potentially unwinding, we're saying if this did unwind, then we are going to go to the unwind handling, and the unwind handling is checking, are we unwinding with this specific token or with something else? Because we are either need to unwind further or we need to stop unwinding. So this is how we do it with a couple of go-tos in C. All right. And this seems to work. So the next plans are that I was thinking that we could test the language a little more by making a simple game for the Ludum Dare, which starts in 2.5 days. So we already have tried doing the raylib, and I guess that's what we will use the raylib to make that game. Now the question is, do we do anything else? What are the other features that are missing from the language right now? And I think the biggest missing thing right now in the C backend is the context. So here's what we want, right? So instead of passing the state of the game, basically, right, into the functions and threading our game state and all of the things here, we don't do the global variables, but we instead do the context variables, where we say that context in the state inside of this loop is equal to that. And then in the frame, we can get a reference to the current state, right? So this is how it is supposed to work, but it doesn't work yet because we have not implemented the context in C over here. How do we compile this? Okay, so if I understand correctly, so when we transpile to JavaScript, the contexts are actually hidden arguments to the functions. But that's not necessarily how we want to implement it. So in a language called Jai, instead the context is a thread local, I believe. So when you declare the context type like that, it means that we have a new field on the context structure. So the new field of name state context and type state basically is what's happening here. So over here we can just have the reference to this stuff. Yeah. Right. So the question is, do we want to do that also, right? Do we want to just to be fields? I feel like it depends on how much do you actually use the contexts, because it's potentially going to be a lot of fields, right? And the way we're doing it in JavaScript, especially so in JavaScript, we don't do the thread locals, and instead, when we say that there is a local context like this, we are creating a new variable context. We copy all of the other fields, and then we override this field just in this scope. And when we exit the scope, we're still using the old context, basically, where this is not present. Right? Right. Bum, 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 bum. Hello, Batcop. So if we steal the idea from Jai, then Jai does not have the ability to say that the context is like local to the scope, and instead we have a different primitive. You found a riddle that the clankers cannot solve? A branch is conflicting with the new commits on main. How do I rebase and choose my edits for every conflict automatically? They say do X hours, but it's X theirs. Yeah. Because they are we, right? Who are trying to merge into the main branch. So okay, so what they have is they have push context push, I don't know, push context something something, push context, chai push context. It's literally just a thing called push context, right? How the implicit context is implemented. Oh, it actually passes a parameter through EDI. I thought it was a thread local variable, so like you don't have to pass it in registers. Is a pointer pinds this RCX. Well, I mean, it does make sense, right? Because, well, yeah. Wait, why don't we just do it? A thing like that. Why is it not thread local storage? It is thread local. It is not thread local. Are you going to do the Ludum there, bad cop? Or are you going to sleep? Well, good night. Hell no. Not going to risk my canceling it halfway in. I'm just trying to decide here how low level do we want to be here. Well, whether it's passed around as an implicit argument or if it is a thread local variable, actually, thread local global variable as an implementation detail, it doesn't really matter, right? We can make it pass around implicitly, that's okay. But we pass around with a pointer, right? And so yeah, so if we want, we can create a full new context. if we want. But if we want, we can just modify the existing one. I think he's handling it the worst way possible always. Yeah, it doesn't matter though, I think. It doesn't matter who is handling the things and how, in my opinion. Right, it's just depending on the people who participate in the Ludum there. Those are the people that matter. No? All that he needs to do is give us the theme, really. And then you go ahead and make a game. You just don't want to enable him. Well, did you see the news that he's been that he like is basically canceling Ludum there already officially, right? And he's asking for someone to make a different Ludum there, right? He's nuts for posting that, right? But he's basically asking for people to take the community somewhere else. Yeah, comparing himself to Linus Torvalds was funny a little bit. Yeah, I remember. Yeah. But do you think that like because he posted that, like you say you don't want to enable him, basically people are just going to participate because it's the last Ludum there, so like it's like a marketing strategy. He's going to like attract more people, and then he's going to cancel the canceling because like I think that can happen. I can see that happening. I actually think that it's very likely to happen that he's going to cancel the canceling. Canceling 3 years in advance, yeah. All right. Anyway, I don't think it matters. Um, that Mike is Mike. It's okay. What matters, like I said, is the people who participate in the jam anyway. You're also busy. All right, I see. What are you working on? Work? You're working on quitting work, right? Okay, so over here, I want this thing to only be available in the current scope, right? And once we go out of the scope, this thing should not be here anymore. And the way we do this is we can save the current context, and we need to restore the context when we go away. Now, is that logic going to be implemented in minicast or in cast, right? So, and if I understand correctly, the Jai way is something like you push context, right? You push context, state context to be this, and then you also defer the pop context, right? Pop context, state context. So we go back to the previous one. Um, I think it's okay if I, for now, just do the defer. Is this Golang? Yeah, this is Golang. This language, the minicast, is basically Golang. You came a little bit too late. I was just showing the if there is not nils, which we have everywhere now. I think defer is one good feature the Go has. I think defer is okay, but since defer is used to clean up the resources, sometimes you need to clean them in a different way because you actually transfer the ownership, and then you need to solve it in a different way. So I think that proper RAI is a much better. Proper RAI with proper move semantics is better than the defer keyword for sure. Bash did it first. Did you know that there's defer in C, by the way? C has defer. Bash has trap. Trap. That's a try catch, right? I don't know. Let's start with this being the primitive. It's maybe too high level, but that's okay, right? But inside, in the C backend, what we will do is we will actually like modify the current. Actually, hold on. Or no. Like the question is the semantics, right? Like we can have the reference to the current state context, right? Like this. But this is the reference to the actual field. In this case, I guess, of the context. And if any of these inner functions are going to modify the context, this reference might be invalidated. Technically. Although, I mean, the functions are supposed to restore the context to the original state, so it doesn't like really matter. I guess. But yeah, using this from like storing the pointer is not necessarily yeah, there are some issues with that, and we will need the borrow checker to like check this stuff later. Okay, let's do this. We're calculating the place, right? So we have the new thing which is called current context, and the string here is the name of the context, right? So this is just the name. So what we are going to do is we are going to reference, this is the place, right? Yeah, this is the place. Place expression is, so we're going to get the field of object, which is, and the object is the current context, right? Which, let's just do it similarly to, so we have scope, which is the context, and I will also want to have the, well, it is kind of like the scope, but let's make it a separate context though. So I want to have the context of type so we're going to have the identifier, which identifies the reference to the current context variable. Scope context var, right? So the variable in which we store the actual context is what we want. So when I do the function is going to have the implicit argument. Sure. So have the new context argument. So name is going to be context variable, right? Context variable is new identifier called context. The type of this is the context type. Let's call it context for now, right? So this is a special type. And this is going to be a first argument of every function. And over here, we're going to say that the current scope context variable is going to be equal to context variable when we are calculating the body of a function. Whenever we call a function now, whenever we call a function, we need to add a new argument as the first argument here, right? So we need to push back the context argument, right? So that is going to be the identifier current context scope, current scope context variable. That's the first argument to every function call. Although technically it should not be to all the function calls, right? Only to those function calls that are having the cast calling convention, basically, right? If we're calling into C, then we don't want that. So when we say the current context of the name, the object is going to be the identifier. So we're going, so because the, yeah, and the context variable should be, I think, a pointer actually to the context, right? Yeah, for sure. I think this should be a reference to the context, right? So when we say current context, we want to deref the current scope context variable, and we want to get the field there, which is this name. So we have get set. Like that. That is going to work, but, and then we have the inject context, right? So whenever we inject the context, we want to know the name of the context and the value of it. Right? We have name, which is a string, and value, which is expression. So we want to say that value is calculate value. And this is where, so like inject the context is supposed to inject it for the duration of the current scope, right? So we kind of just want to mutate it here, and we want to say that current scope context variable. Well, I mean, the way we are doing it in JavaScript is that we're creating actually a new context variable, right? Which is created by copying the old context. But I feel like copying the context is not the efficient way of doing it. And the efficient way of doing it is actually saving only this field in a temporary variable in this scope. And then when we do want to and then we want to defer the thing, you know? Yeah, we want to defer the thing. to restore the context after we exit this current scope. Which maybe we just want the defer keyword here. Anyway, well, I mean, we can implement it internally, but we might as well just have the defer as a dedicated thing. So that's what I was thinking about. We could instead make this not hard-coded, but being like actually explicit in minicast. Right, like what we want is we want to first assign insert statement. Right, we're going to assign to the field where the object is dereference, the identifier, current context, field is name, right? So same as when we were retrieving the context, but over here we're assigning to this context variable, right? And we're going to say that value is this, right? Well, we're going to say that if value expression is some value, because if this value is to void, we don't want to store the void. Right? We actually don't do anything else other than calculating the value. If this is void, it is an imaginary field which doesn't exist in this case. So we're going to assign this to the value, but this is just overriding it, right? So, and what we want is we want to restore the context to be the previous context when we exit the scope. Which means that we want to defer let's say we want to defer the function like this, right? And this is going to say that the current context var so defer is the block that is going to be called into like into ways. First, it's going to be called if we are going to exit the scope normally, but also it should be done if we exit the scope with unwinding. It then also should be changed. But then also later when we have the continuation stuff, it is also going to be a little bit weird there. But I guess the continuations would, like, that's where we would have to clone the context. Right. Let's ignore the potential performance overhead for now of that, and we're not having the continuations yet, so it's whatever. Right. Yeah, but I want to current context place name. How about this? Current context place name string. This should return the place, which is this thing. So we are going to reuse the same stuff for the current context expression and the inject context. Right, instead of doing this, we're going to say that current context place of this name, we're going to set this to be value. There you go. Right? And we're going to defer saying that current context place, that context is current context place name. There we go. Context set value and context set old value, right? So we're going to defer changing the context to the old value. There we go. We just need to retrieve the old value, right? And we just do the get here, right? And we are going to say that. So we're going, yeah. So we need like old value variable, right? So we're going to set it to be equal to the identifier old value var. So old value var is new identifier old context, right? And we're going to let var value expression type is the type of this variable. The name is going to be the old value var, and the value is context get. This gives me the pure, so I need to say pure like that, right? And then we defer setting the context to be equal to the old value. I think this might be it. I just need to figure out how to do the defer. So defer is f, which is a function that is going to be called at the end of the scope. Right? So it actually is going to be called twice. First as the normal, and then as the unwinding scope. So it is going to be actually kind of similar to unwinding, I think. So I need to actually mutate the current. Right, we have the unwind context. Right, we have current unwind context, and we can change the how do we insert the unwind instructions. Right? So for example, when we have the explicit unwindable block, we say that unwinding is going to the car handle unwind label, and we are going to have similar with the defer block. So we're going to need to mutate current unwind context. Unwind context. We're going to say unwind context. Insert unwind. So we need to create a new label. handle unwind label, right? New identifier handle unwind. Then we want to have like after like okay, like after defer label for defer. So basically we have the defer statement, right? We're going to inject the block which is handling the unwinding, and then we're going to skip over this block. Right? So we're going to insert the statement go to after the defer. But then we're going to say that right after that we have the label, which is handle unwind label. And then in the very end, we're going to have the label, which is after defer label. And so in between these two labels, we have the actual handling of the unwinding. And whenever we do want to handle the unwinding, right? So right here we have to do handle unwinding. And well, I mean, what do we do to handle the unwinding? We actually insert the unwind. We actually insert the unwind using the current way of inserting the unwinds. So yeah, we basically continue the unwinding. There is nothing to check here, right? But before we continue the unwind, we need to actually call this function, right? So we just call the function f here, right? And then we say that we want to insert unwind, and that is going to be the statement, which is go to handle unwind label, right? So that's how we are handling unwinds now. After the defer, we are unwinding to the defer handling of the unwind. And then the other thing is that we want, after we close the scope, right? So we want to say current scope. So I guess that we do have the scopes, right? Do we have the scopes? It's kind of a little bit weird that I am like using multiple different contexts here. Like I want them to match, actually. Right? Like maybe it's part of the unwind context, actually. You know? So when we... So this is not the unwind, but this is cleanup scope thing, maybe, right? And this is going to be a function which just calls the function f, I guess. That's it. So this is cleanup scope. Without unwinding specifically, right? So yeah, we are calling this function on defer on like the successful execution and on the unwinding. So we have insert unwind, and we have a cleanup scope without unwind, which is another function. Right? So for example, over here, we're doing the unwindable. In this case, the cleanup scope is going to be nothing. Wait. No, it's not nothing, actually. Cleanup scope without unwind. is a function. Well, I mean, this is not doing anything, right? But like, since I'm introducing this this cleaning up the scope, we should actually call it, right? So this is the unwindable handler, and if unwindable handler is doing it without unwinding, right? Then we need to clean up the scope, right? So over here, I need to actually say current unwind context clean up scope without unwind, right? Because this may be like mutated while I'm calculating the body, because if the body has the defer statement, this will be changed, right? Oh, but I need to not ignore the previous one, right? So we need to actually call this function, but we also need to clean up the previous one, right? Previous cleanup scope without unwind is unwind context cleanup scope. So we need to like first do this, the defer, and we need to do it in the reverse order, right? So we're going to call this function afterwards. Okay. Right. So this is actually going to be called if we never did unwind. Okay, good. And this is when I have the function definition. Cleanup scope without unwind also is that. So if the function did not unwind, over here, right, after calculating the body, if it did not unwind, then we want to say unwind context cleanup scope without unwind. Is that right? So there's only like two places where we initialize the unwind context, and this is either the unwindable block or the body of the function, which is also the unwindable block, which allows me to return. Yeah. Okay, that sounds good. Now, is it going to work? I kind of want to, since we do have that, actually introduce the syntax for deferring then. Right? Can I say syntax defer is defer with expression, I guess we're deferring. So let's implement it then. When I'm parsing an expression, right? Parse defer. We say that expression is expect single child with no name. So do I just return here, right? This is going to be the defer. Type is going to be unit. But we're deferring the expression, which is parse expression. The defer expression should return a unit, like that, right? So that's all. That's how we do the parse defer. which means that we need to have a new kind of expression, right? Called the defer expression. And when we have the compiler to see, if we have the defer expression, well, this should return void, but we want to actually defer, and this is the function which is going to calculate expression in the defer block. So we're going to calculate this thing twice, actually. Which I guess does make sense. And we're going to ignore the result value of it, yeah. All right, let's see if it works. Parsed expression shape is not defer, right? Because this is expression. Not a place expression. Defer is very like similarly named to deref. Is there a better name for it than defer and deref? Oh, current context place. All right, I need this span here, I suppose. Statement is not unit over here because yeah. So inject context, they should return something, but it doesn't actually return anything. So we need to return void. Right? Injecting the context does not have the value. Oh wait, but defer is not going to work properly on like. Yeah, it's not like working with the scopes. The defer is deferring a little bit too late because I'm not creating the new thing on this scope actually. Right? Yeah. Which is, yeah, I don't know, maybe we should have merged the types. What's the issue here? Context var type ref named context ref. what are the types that we have? Oh, it's a pointer, it's not a ref, right? So this is a pointer to the context. But this is still called named. Oh, and this should be like struct. It's not just named, it's a struct, right? In C, they should be struct. And also, I just realized that I never like make the definition of what the struct context is, right? String is not ident. Is it still here? It's a pointer to struct identifier context. Well, if I remove this, it still does not compile. So the issue is not here. String is not identifier. Oh, this seems correct. I don't see issues. Alright, why is my error message so bad though? String is not identifier. I think that we might just need to recompile from scratch here. Maybe it's the incremental compilation bug again. So yeah, what's missing is that we cannot really call into the C functions this way, right? Yeah. And we also don't specify the type of the context. Yeah. And we don't create the original context. So in main, we should create the original context, which is going to be just empty, uninitialized one. Okay, yeah, it did compile. Okay, good. Just let's try to go to Rayloop here immediately. Yeah, there we go. So we have like the draw texture, which is called with the context variable, which is actually not expected, right? So Windows should close is defined in raylib, and it does not have any arguments like the context, right? So which means that we might, so like there are also multiple ways of solving this, right? Right now we have the really bindings like that, where we say that like initialize window, right, is a function which is native function, but native function still has like is assuming the same calling convention. We could instead do like I was doing it previously, where we wrap it into our own custom function, or we could say that well, I mean, we could figure out if the function is actually the native function or not native function, and then do different convention because of that. But maybe we would actually want to specify uh, the thing. I also just realized if we do the context as like the global type, having all of the fields, it means that we cannot do separate compilation. Is that the reason why Jai is not doing separate compilation? One of the reasons. You need to know about all of the contexts that are possible in the program before you can compile anything. So one way is to make this not native, but instead do it like I was doing it previously. Oh, which maybe is fine, you know? Maybe it's fine. Right, like init window is calling init window. But we could say native init window. And this is now the C calling convention. If we do that. Right? It's either this, or I need to specify that the so we would know the function type. What is the calling convention of the function type, right? Which I think is maybe fine. But it also means that when I'm specifying the type, or specifying the function, right, I need to specify the calling convention. Or like, we do like extern C. Is that what we do? Call C. What's the good syntax for this? What are the other languages do, right? Oh, you can say like default calling convention is std. Foreign procedural declarations have the C colon convention by default. Oh, okay. We can do like similarly to that. They do in Odin here. So this over here is the foreign function, right? So we could default this, and then like if later we actually want to support the other one, we could then figure it out, right? Yeah. I'm still wondering what's the syntax for. Oh, you say like you say proxy. There you go. Right, because they do require the keyword proc. But since I don't have the keyword here, I need to put this somewhere still. Um, I mean, yeah, I could have something like that annotation instead. Boom, boom. So we have the type, which is a function, right? Function type, and the function type should have uh the calling convention, right? And calling convention. Yeah, I don't know. Let's just say optional string here. Maybe. Maybe that does make sense. So when we have the native function like this, I will say call using the C convention. Yeah, sure. Let's do that actually. So the mini syntax should have the function type, I guess, right? Function type with calling convention. So we have call convention. Call convention. So this is an optional thing which is present before this thing. Yeah, sure. So then we have the parsing of the types. If we have the function type, well, I'm actually now expecting the 3 children. Well, now it's not, yeah, now this child is optional actually. Okay. Let's say that args est is root children. Tuple get named args, right? AST expect unwrap child value. Result is root children. I to also like this is a reference, and this needs to be dereferenced, right? Result in Rx. And then the calling convention, right? So call convention is root children. So this would be get named opt. Call convention, right? So we're going to match this. If it is none, then it's going to be none. But if it is some group, then we want group children group unwrap expect single child with no name, and this is my stuff, right? So call convention is an optional AST, right? And so over here we have the function type, right? Call convention. This is supposed to be a string. So this call convention, yeah, this is a string, right? So we want to expect single child, and then we want to say AST expect string. AST helpers still. Expect string. Sure, and that is going to be my calling convention. It's an optional string, just like we expect here, right? So when I want to parse the function, function type, calling convention is going to be none here. I will like later support defining the functions with calling convention too, I suppose. When I process function declaration, I want this function type also to be the call convention is none. Child is not group. Oh, this is a child, right? Some child. Child is the unwrap child group, right? It's a group with a single child there. args ASD. Can't find args ASD in scope. Wait, what? Why not? Isn't it like literally over here? Oh, it's arg ASTs, not args AST. Got it. And when we have the function here, this is resolving type aliases. Call convention is just going to pass over here. Call convention will be ignored when I'm making sure that everything is defined. When I'm doing the wait, hold on. What about the type checking? Yeah, when I have the type checking, I need to say that if we want the calling conventions to be the same. Which also means when I want to print the type, right? If I'm printing the function type over here, right? I will say that if self call convention is some string, then we need to write call escape string s and a space, right? Okay, this seems like it is compiled, but I did not handle it yet in the C, right? So when I do generate calling the function, right? I need to figure out the type of this function. And this argument, which is the scope context variable, is only going to be done there if there is no calling convention, which is the default minicast calling convention, right? So, okay. Match. Let f type is match f type with function type and type. Anything else, then we want to report the diagnostic here. This is weird though. This should be like internal error, right? There is no related also. This is going to be f span expected a function type, but it's not a function type, right? So now we have the function type here, and I basically say that right, we're going to say if function type calling convention is none, only then we're going to add this context argument as the first thing, right? This is still not it fully. I just still did not generate the context type. Could not find function type. I call it F type. Right, we're compiled. Hopefully the next error is that the context type has not been declared. No, cannot finish parsing the call. Unexpected token, semicolon. Wait, what? Why not? We have call underscore. Mini syntax. Call underscore. Oh, we have the args then. I see. Wait, what? Yeah. I understand why. I do understand why it is done like that. Why is it parsing like this? Because it's basically parsing this as the function type. Wait, what? No. No, that's not the case. It's not supposed to be able to parse itself. What's the error? Yeah, like call underscore. Oh, wait. Wait, what? No. It's a little weird. I think that this is the left-hand side of the function. Yeah, I need to like specify my syntax better a little bit. Like this should be the identifier, basically, is what I'm saying. Right? I could make sure that the arguments here are how do I do that here? Like I can say that this is more than or equal than 5,000, for example, which is going to like only allow the simple tokens there. And then that's going to work. I could have the calling convention. Actually, you know what? What if we do calling convention? I mean, yeah, it's supposed to be a single token there, right? No expression. Let's just say more than or equal than 5,000. A little hacky, but that's okay. Just trailib. Okay, so now it's parsed. So now the C is not doing it, right? We have conflicting types for is unwinding with. But why? I'm specifying it twice. No, I'm not specifying it twice. Then why do I have the conflicting types? I think it's because the first error is actually different, right? It's because we need to look at the first error in C, not at the last error. And there's a lot of errors. Declaration of struct context will not be visible outside of this function. What does this even mean? That's okay. It's probably because like the context is not defined though, right? So this is the argument, the context argument to this function, and it's, yeah. But then we have the conflicting types for string to C string. Wait, what? That makes no sense though. So you're saying that even though I'm saying struct context are here and struct context are over there, these are different struct contexts? So like this context and this context is different type. Is that why? If I do say struct type def, struct context though, context, then the errors do go away. So this error is very misleading. I feel like, right? And then the only error is that we don't have the state context. A new raw unwind token. This should be not the thing. I mean, I guess in this case, I do want this to be the C calling convention. And I don't want it to have the context. Also, we can like not generate the unwinding checking if we're calling the native function, right? Because only the cast calling convention specifies that the functions can be unwindable, right? I could generate a little simpler code then, potentially. Okay, call convention. Let's do the calling convention over here. Optional in the function definition too. Then I think that's okay. But I am calling new raw unwind token right over here, and because I'm calling it like this, that is why it's calling it with the normal convention. But so like it's assuming that this is the C calling convention, not the cast calling convention, when I call the function like that, which should not be happening. Although I think this specific function should be declared as the C calling convention, like this. But what happens when I call the function that potentially like panics there? It means that this function should also be. I feel like it should be undefined behavior if I do unwinding from within the C calling convention. Unless I actually handle the unwind. Right. I think that would be fine. We can also then prevent the unwinding on calling these like different math functions. So, which is going to result in faster code too, I suppose. So all of these functions should be call C functions, right? Allocate on heap should be call C. Allocate on stack. I mean, yeah, a bunch of these things. Call C. Call C. Call C. All right, let's do the context when I do generate this C, right? So here's what we're doing. We're having the program, and program should have a type. Right? I'm defining the type. And I need to define the type called context. And that's going to be a special one, right? So this is going to be the last type that we add, which is the context type definition. So we have context, program contexts, I think. Right? Let's see, contexts. Right, so which is just basically a map from string to type, which is all of the fields that we need in the context structure. So context type def is going to be a struct with context fields. Context fields. That's going to be an array there, right? And then we go for name. Value is type. In context, or in contexts, ord map iter. So we're iterating over all of the contexts, and we say context fields. Push back field. So field is name is the identifier name, and type is convert type, right? And this is the struct. No, then definition is this, like we have name. Context definition, right? So context definition is name is identifier context. Definition is struct with context fields. So now we should be able to have the context definition there. And the only problem is that I'm not calling the function main. Here's what I'm doing right now. I'm saying that I'm defining main to be mini cast main, and then I'm calling it, because main in caster is returning void, right? Which means that over here I actually need to add another thing. Let's do that. Undef main int main minicast main returns 0. Like that. Okay, I just want to say that this should be done with the context, and we say have the context. This is uninitialized variable, and this is totally fine. Is that all? No, I also wanted to have the calling convention to support that on the function definitions, which I did not do yet. It says unexpected int. Wait, what? Why not? The parse error? No, there's something wrong here. This is a multi-line string. This is supposed to be a string. Why are you saying unexpected int? You're lying to me. My language server can do that. Why you cannot? Why do you think that is an identifier? Let's try this. Kast. Parse source mini backends c print. Oh, I cannot parse because yeah. Oh, wait. It's because the multi-line strings are not supported in the Bootstrap. Oh, that's right. I did not do this in Bootstrap. Do I fix my Bootstrap real quick to support the multi-line strings? It's kind of annoying. I need to go there. No. I don't want to do this. I'm too lazy. This would be nice, but let's instead do a regular string here. Let's do a regular string here. How about we actually do this? Eval std fs read file std path dir name of the file plus you know main.c. Meh. It's okay. We're just going to do this. This is my main. Which is going to be in the end. Where's runtime C being printed, by the way? Oh, I'm preventing it on like the out. Yeah, this should be like embedded there too, I suppose. That's okay for now, though. So the last part is the calling convention on the parse function definition, right? Yeah. And this should also be different here. Result type. I can also actually make it emit the result type, which is going to make this be the unit by default if we wanted on the function declarations. Fields. Oh, we want struct with fields. Actually, like, shouldn't it panic then? Oh, maybe expect 3 children is actually not. Yeah, it's not actually checking that there is that these are the only children, which is why it's not panicking, I guess. Okay. Too few arguments. So this is the only error now that we have over here, right? Which is unwinding with this. This should be identifier, not raw, so that we don't surround it. And this could be identifiers too. Well, in this case, it should be ident, but that's okay. So is unwinding with is a function defined over here, and this is expecting 2 arguments because this is supposed to be the calling convention there of the cast, but we want to say that this calls C, right? Yep. And we want then to actually implement it. Okay. So let's do this. Let's call convention is so this must be a function, right? Call convention is parse call convention from the root. And then we'll do the same over here too. And what am I trying to do? Starful morning. Hello, hello. I'm making my programming language here, and right now I'm making the calling convention, which has the implicit context argument. If that makes sense. So we have the context system in the programming language, which is similar to the context system that you might have seen in Jai or Odin. And we do that by passing an implicit context pointer to every function call. But we don't want that to be done when I'm interfacing with C, so we introduce the calling conventions. Right. Yep. Well, this should not be even. I don't care about that, right? Only about figuring out the type. What language is this? This on the screen is also my language. I have already made the somewhat working language previously, and I'm writing my language in my language now, which is self-hosting. Although I'm not working on rewriting the language completely yet, I'm making a simpler language first. German? No, not German. It's called Kast, this language. Maybe we do have the call convention here after all in the function definition and in the function type. So this is not none. This is the actual call convention which we have parsed. So I will say parse call convention is the group, and this should give me optional string. It's a coding language, a programming language. This is what we want. So call convention is either present or not. If it's present, then it must be a string. Okay. And then so now the function definition also has the call convention, which is optional string. And this is, so now that we have the function definition like that, when I'm generating the function, right? When I'm generating the function in this C backend, over here, right, we have the definition. So I have this argument called context as the first argument that this should be only if definition call convention is none, right? Yeah. Right now I'm just treating any convention as being like without the context, but wouldn't actually care that it's calling convention C or any other one. Yeah, so we just don't have the context argument for the C conventions. Okay, good. Okay, it might work now. My language compiles to native bytecode. No. Right now I'm working on transpiling to C. The bootstrap is transpiling to JavaScript. And also has the interpreter. And it did compile. Okay, there we go. So I'm compiling to C. Here's my generated C code. But I'm technically having two languages right now, right? One is the Bootstrap, and another one is one what I'm working on, right? So they are called Kast and Minicast. One is the simpler. It's going to be used as an intermediate compilation target, basically later. So here is my generated C code. And what we want is to look at, yeah, so like, yeah, there we go. So we are loading the texture. This is going directly from the raylib. And it sounds like intermittent presentation, like LLVM. Yeah, but a lot more high level. It's not like a low level one. Well, I mean, I don't know. There is a lot of high level features in LLVM too, but yeah. Yeah. And also I have this like textual representation of the minicast. I guess like there is the textual representation of the LLVM too, but it's basically like a programming language. As you, I mean, this is Kast. That's not minicast. The minicast is raylib main, right? This is the function that I'm trying to do, right? I mean, I'm interfacing with LLV with raylib and making this simple thing. So this is like a regular programming language, kind of, right? And we have some high-level functionalities like unwinding. Is pretty high level, I guess. And the context system also. There's also going to be the delimited continuations, I think, here too. There is also a little bit of the templates, which are more like C++, I guess. Right, so I can have generic structs like this, which are being monomorphized, which is basically the templates, just like in C++, right? Although some features I'm omitting here, like I don't have the operators, and instead we make the native like so I can embed C code basically like this. And instead of the operators, we have the functions. Because like I'm not really planning to write this language manually. I'm planning to use it as an intermediate language. But it's still pretty high level. The main Kast language is a lot more high level than this, where we have the compile time evaluation. It's not templates, but like actual generics, which are being type checked before instantiation. And I don't want to do the monomorphization for them into debug builds either. So yeah, there are things. But yeah. Bum, 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 bum. So what did I want? I mean, technically this works, it seems, right? I have the context, and it did work. We have some warnings about the unused values, but I think that is fine. Can I suppress the warning somehow? I'm returning uninitialized variables, and this is technically not unused. This is supposed to prevent undefined behavior, if I understand correctly. This C. A returning uninitialized thing is undefined behavior unless we take the address of it. So I would like to get rid of this warning. And then this is a label followed by this. Okay. Let me do one more thing, right? So like I said, when we're trying to call a function, which is a function which is a C calling convention function, right? Then I don't need to check for unwinding. right? Yeah. So I only do this if function type call convention is none. Only then I'm going to check for unwinding, right? So a little less overhead for calling C functions. Okay, and we also have the defer statements. I want to try something simpler. Can I have the mini cast test mini test? Oh, we do have like this. We have debug, print, and print. This is when I was testing the JavaScript though. Now I want to test the C. I don't work as compiler engineer now. Oh, context is just a string, right? Yeah. I don't want this. SU, what is this? This is some weird stuff. I want to test the context here. Like that. This is also some recursion. This is a closure, which I don't support yet. So let's let's actually get rid of this. I just want to test the context here, right? So context inside, outside, and that's it. Right. So I'm just going to have the print. Yeah. Print. And this is going to be printf. Printf as contents. So what do I want to do? I want to like just C tests mini test. Variable has incomplete type, row unwind token. Oh, I need to prepend probably, right? Just see runtime. Okay, that works. If I'm printing the line here, can I do %s/n as contents like this? Okay, there we go. So we have outside, inside, inside, and this is not the correct output, right? Because so what we're doing here, we have the context outside. This is supposed to be the context in this scope. Inside of this scope, we are supposed to have inside. So like this should print inside, this should print outside before we introduce the inside context, and this should exit this scope, which should reset the context to be this, right? Which means that, yeah, that's what I was talking about, right? If I have the and in general we have like defer, right? If I say defer over here, if I say defer print print exited scope, right? Right, so it says exited scope over here in the end after we actually do over here print exited main, right? So it's going to print exited main first and then exited scope, which is not correct, obviously, right? So how do we do this? It means that when I do this scope in C, scope over here, right, we have this scope, and I need to say that unwind context is unwind insert unwind is current unwind context insert unwind, right? But cleanup scope without unwind is going to be the empty one here. And then we okay, right, so now we say that result is calculate expression, and then we return the result. But before returning the result, after calculating expression, I'm going to say current unwind context cleanup without unwind, right? Like this. Yep. Yeah, I have a feeling that maybe like merging these two contexts would be better to not have potential bugs like this. Let's also recompile completely from scratch so that my LSP picks up with the new syntax. Oh no, we have officially bypassed the 1 minute compilation times. Oh no. How much code do I have? 16,000 lines of Kast, plus 2,000 in standard library, 18,000 lines. Oh no. I'm actually thinking like the minicast is kind of a language. I imagine that the minicast would be compiling relatively fast compared to Kast for now. There's no way I'm going to rewrite this stuff from Kast to minicast though, right? No way. No. I read any books? No, I have not read much books. Well, I mean, I did read a little bit of the things sometimes. This seems like it's correct, by the way. Now, this is the correct output. I know that there are some things, like I've been reading the art, like a little bit on the specific topics that I'm interested. I think in general, making the language is relatively straightforward. To be honest, it's not that difficult. There are certain like things though that I did read about, but even those things that I read about, I don't know. I mean, it depends. Because I have been thinking about making the language for a long time, right? I only started recently, but I've been thinking about it for a while. The thing that we usually recommend is crafting interpreters, even although I didn't really read it myself. craftinginterpreters.com over here guides you through making the language, starting with the interpreter, transpiling, compiling to interpreter representation, optimizing, bytecode, machine code, all of that stuff. So I feel like the only thing I know about this book though is this image. I have not read it, but I'm pretty sure it's a good one. Would you like to work on a compiler? Well, I would like to work on Kast. If I was being paid money to work on this, that would be nice, right? It's a little bit weird to like. Let's say that I was to have a job as a compiler engineer, but I was making a language that is not Kast. Would that be like fun? I don't know. I'm trying to make a specific language, not just any language, right? It's like I don't know. Do you want to work as a game developer, or like in a AAA company, or do you want to just be an indie game dev and like making everything solo? It's like completely different things, you know? Okay, so I have the actually correct output now. The raylib is working, it seems, still. Should we take a look at the generated C code now? Here's my main, right? So we have a couple of go-tos here, but right. So over here, I'm calling therinit window. This is the function which is having the cast calling convention, so it takes the context as an argument, right? But the function like set target FPS, which is this is directly the binding to the raylib, so we don't check for unwinding here after calling that. Okay. Yeah. Over here we have defer. So this is handling the deferring here, right? And this is me restoring the context to the old context, right? So this is me deferring. Yep, makes sense. I don't know. Like, what else is missing then? Now, let's say that we have context system working in C, supposedly. What's the next step? What's the next step? Should we like try making a more complicated game or something? One of the things that I'm not doing right now is I'm not like managing my memory at all, right? I'm never freeing memory. Well, I'm not really like allocating memory right now either. Unless it's on the stack. So we want to have an example which would do that, right? Right. So let's try to make... I do have a list though, right? But the list, what is a list? Lists are like strings right now. where we have the pointer to the first element and the length. We don't have the capacity here, right? So this is not a dynamic thing. We can allocate the list of the specific length. We are not freeing it ever, though. Right. Maybe we should have the free list t. List is a reference to, well, just list t, I guess, right? I'm thinking this, like, this should be optional, right? Returning nothing. If I want to be a little nicer to write by hand. Native. So how do you do it? You just do the free. You just do the free of you just do the free of the list data, and that's all. Let's say that we want to have a test where we specify the type vector, right? Let's call it vector here. It's okay. Vector t. So we have the it's a struct with data being the list of t's. So this is like a primitive actually in minicast, right? Right now. I mean, and actually not, because it's defined in the standard library anyway. Data. And then we have like the length. So the length of the data, I guess, of the buffer, right? We call it buffer maybe. So the length of the buffer is the capacity, and this is the actual length. Right? So then I would say new vector t. This should return vector t. So we are doing the buffer is allocate list. Hello, Tommy Luca. Still rocking the Cosmic desktop. The Cosmic desktop? That's a Hyperland. I'm not doing Cosmic. Cosmic is a different thing. No. I never did Cosmic. So length is going to be 0. But what's the initial capacity? How do you usually do, like in C++? What's the original capacity of a vector? Is it 1? Is it 0? Wait, what happened? Wait, can you even allocate? Can you do malloc of 0 in C? What's going to happen? Does malloc even works with 0? Seems like we are not, like, we're doing the exit code 0 and everything. Malloc. If size is 0, the behavior is implementation defined. For example, a null pointer may be returned. Alternatively, a null pointer may be returned. Such a pointer should not be dereferenced and should not be passed to free. Wait, it should not... Wait a second. Should be passed to free to avoid memory leaks, right? So you should still free the stuff that you allocate of size 0, right? Should you free it even if it's null in the implementation? Or is it, or is the, or is this going for the alternative thing? Oh, it returns a null pointer on failure, right? So it actually is a failure. So when you do the 0, it might fail or it might not fail. But it should not be the reference, which makes sense, right? I feel like, though, maybe we should never do that, right? I can just do no allocation by default, right? I can do no allocation by default. Empty list of type T. Right? Can I say empty list returns a list T? And this is going to be data. So data in this case is going to be null. Is null like the thing? Or should I say 0 here? Length is 0. And free list, this should not be freed, right? So this should only be called if the data is not nil, right? If data is not, that doesn't work. If not equal, then we're going to free. List data is not equal to null, right? Then we call the free. We can do a call C here so that there is less overhead, but doesn't really matter much, I guess. Let's right here. So we have the empty list, and this is the new vector, and then we want to be able to push to the vector, right? T, which is going to have the vector, which is a reference to vector T, and then we have the element, which is T, right? This doesn't return anything. So this should say that if v length is equal to the v buffer length, right? Then we need to reallocate, right? First, all of the things. Then after we have enough capacity, we're going to say that so we have like list index, right? List index. V buffer at index v length. This gives me the reference, so we dereference that, and that's going to be equal to element, right? And v length is at v length and 1. So if this was equal to that, then we need to figure out the new capacity, right? New capacity is going to be equal to, I kind of want to just multiply the v buffer length by 2, right? But if the new capacity is equal to 0 still, because it was originally 0, right? I should the if be first. Maybe if should be first. Maybe this. We say that if we do this, if equal the v buffer length, if that's equal to 0, then we're going to say that the original capacity is going to be like 4, for example. Right? Otherwise, we multiply the previous capacity by 2. And then we want to say that a new buffer is allocate the list of size new capacity. And then we want to do a for loop. Wait, do I have a for loop? I don't have a for loop, right? We can do a native one here, but yeah. We don't need a for loop though, really. We can do unwindable block, unwindable loop. Well, I mean, we want to kind of have the mem copy here, right? Because, yeah, we just want to do the mem copy, actually. Because we want it to be efficient, right? Especially when we are targeting C. I want to, like, not really have too much. It's okay. Let's say native mem copy. Mem copy into the target. Target is going to be the new buffer dot data, right? The source is going to be the old buffer, so v buffer data, right? And the length data size. Data size is we need to multiply. We need to multiply the okay. T type info is type info t, right? So say t type info dot stride. We need to multiply that by the v buffer length, so like the old buffer size, right? And that's what we want to copy. Yeah, I think like we should have these things as the native ones after all. Well, I mean, we'll see. I kind of like forgetting about my JavaScript backend, but I will want to have it, right? Still. Let's see, let v is new vector of int, right? And then we say push to the v1, 2, 3, 4, 5, 6, 7. Number literal cannot be size t. Wait, what? Why not? I need to make sure that it can be size t, I think. What about my type infos? They also are size t's, all right. Let's ignore this issue for now. But I should allow that to work. Size T's, right? And it should be int. I might like actually implement the inference for the template arguments here. It's not that difficult. Oh, should I say over here that this is size T? Otherwise it doesn't, it like defaults to this type, which is also defaulting to unit. Oh, what list index? Should list in, yeah, hold on. List index takes the integer. Now. This is a different type now. Now I need to convert the length into the int. Right? Expected int got size T. Should we index into the arrays actually using the size T's here? That probably makes sense, right? No, it should not be that. I think. It does make sense for C, but in general. Unless it makes size T to be like actually a built-in one. I do have the uint. I could make it a uint. Which also means that I actually don't want to have size T's anywhere, kind of. Do I? I just want to say uint. That's like what I added it for, right? And uint is the size T, basically. I just don't need it to be the dedicated. And uints can be the things. Yes, okay. We just do say 4 then, 2 and 0. And we don't need to do that. Number literal cannot be uint. Wait, what? No, it should be uint. No, that is not right. We have int, we have uint, and then we have the specific ints. These are not specifics, but these are still the raw integer literals. Yeah. And indexing using uints does make sense. Use of undeclared identifier int type info. Did you mean t type info is int type info, right? Because t is int in this case. I'm not making the int type info. I am supposed to generate it though, right? And I'm not generating it. Is it because of the type info over here? We have the type info. Or is it because it's an alias? Hold on. No, I did resolve the aliases though, right? Int type info. How is this supposed to work? I mean, like, yeah. It's not supposed to be there. I'm temporarily adding this as uninitialized. Oh, wait, is this still the issue where I don't transpile the constants? I think that might be it. I think that might be it. I think I still don't transpile the constants. Let's try this different example right now. Let's do it in this file, right? Can I say const 10 int is equal to 10, right? And then we use it over here, 10. And it's just not going to work, right? Yes, because 10 is undeclared. Okay. I need the constants to be transpiled. I do generate them. So when I compile the program, the result, we do have the result. The result has includes types and functions, but we also should have the constants. And this is going to be a list of constants. Constant in C. Our const comp time only in Kast. Well, what does it mean comp time only? You can't use the constants at runtime, right? But they are calculated at compile time, yes. Is constant C not a compile time though? Is constant C actually allowing you to do some complex expressions when you initialize them? I thought you cannot, because that would mean a static variable, right? Which is different from a constant. Yeah. In Rust, you also have consts, which are different from non-mutable values. That's different. And consts in Rust are evaluated at compile time. Constancy is a type qualifier. Oh, that's just a type qualifier, right? Yeah, not in Rust though. In Rust, it's not just a type qualifier. Right. Yeah. Which means that you can. But can you like initialize the thing in C here? Can I say like int foo, which like returns 1, 2, 3, and then can I say const int foo is foo? No, right? Yeah, because we need to initialize it to a compile time constant. Yes. You can even cast const to non-constancy. Yeah. No, for the non-mutable variables, we just have the non-mutable variables, just like in Rust. Although in minicast, I don't have the mutability. So in cast, every variable is mutable and every constant is compile time evaluated constant, which doesn't, which since we don't have the comp time, it's just like, yeah, a thing. Okay, const is, well, I mean, right now I'm having them as expressions, right? So like right now values are expressions, but these must be expressions which are known how to evaluate at compile time, right? And then we have name, which is identifier. So when I'm printing, and also we can forward declare constants in, we can forward declare variables, I guess, the global variables in C. So that's what we're going to do before we even no, not before. I want to forward declare the constants before I do the functions. But maybe like after the function signatures. Over here for const C in program consts const be lower to C at all. Yeah. Why not? How else would I? Well, I mean, are you saying that I should inline them in the functions? We could do that, I suppose, but um, but it's not. Yeah, no, that's not always possible, actually. Because we can have constants which are referring to each other, actually. You can maybe do it with the preprocessor. Yeah, but why? Why would we not want to do that? A constant is just a value evaluated at compile time in Kast. In minicast specifically, we don't have compile time evaluation, so it is just a thing, I guess, which must be a compiled time evaluatable expression kind of thing, like just like in C. The best way would be to evaluate them to a single constant value and then lower them. Well, that's what I'm doing, yeah. In Kast, we have like basically we yeah, I am not lowering const expressions. No, yes, that's already the case. So whenever in Kast I am seeing a reference to a compile time constant, I'm creating a constant. I'm not creating the const expression in place, right? And I'm referencing this value, which might be also referenced in other functions, right? So that we like have this done only once. You know what I mean? I can show you maybe the transpiled JavaScript, I guess. Over here, which is pretty big now. We have 120,000 lines. Yeah, over here. These are all the constants, right? So for example, expected group, right? This is the string constant, which like I'm doing for the error like error reporting, right? This is the string literal. It is just living in the global in a global variable in JavaScript here, right? And in C that would be also like a global constant instead. And there's a bunch of these things. You can see the over here, right? Like what is this? What is this value over here? This value is the standard library. Standard library is also just a constant which has the ASD, which is a type, the boolean, which is a type, and like all of the things in standard library, like dbg is the debug sub module in the standard library, which is this, which has the print function, which is also just a global constant. Right? I don't know. So yeah, every variable, every constant which is captured by the stuff that we're compiling is just becoming the global constant. Yeah. I don't even like store them in Kast as the expressions anymore. I'm storing them literally as references to values evaluated at compile time. So I need to transpile the values, right? So in order to transpile a value, we make sure. Well, I mean, I guess we could like duplicate them, but that would be like too much. There's no way we would be doing that. Yeah. Okay, constant is AST const. So we want to write keyword const, and then we want to write okay, but the const then should have also the type, right? Const print type const type. Then we write and we print. Oh, then we write a space. Then we print identifier. Const name. Then we write equal. And then we print expression. Const value. Okay, that's all. And then I just need to, in C over here, to actually do it, right? Yeah. So we say for so this, we have the const order here. Okay, for name in context program const order. We say that const itself. Well, this is the value, right? Which is going to be the context program const map get name unwrap. It must be there. And then we say context result const push back the const, and const is, so the type is convert the type. Well, first we need to say that value is calculate. So since I need to like if this is an expression. Wait, but is it not undefined behavior? Okay, what I can do is I can like create the initialization of the variables actually instead of here to be over here before main. Maybe this is actually what I want to do in case of a more complicated expressions. Right? Like we can do this. But this is not going to work because we cannot assign to foo with a const qualified. Can we cast it here? So you're saying that we can like we can say we can do this. We can cast the reference to const to a reference to a non-const and then assign it. Is this not undefined behavior in C? It is. It's printing 0, right? This expression cannot be complicated if they are already fully evaluated, right? Yeah, they're supposed to be not complicated, right? Yeah, exactly. I'm just lazy to create the dedicated expression type, which is like a pure expression, but it's supposed to be a pure expression, right? With no side effects and stuff. Yes, indeed. I mean, we can check it, right? We can check it here that it does not do, but like because we want to calculate here, it means that we need to, just in case, because I'm like actually checking it in the, I mean, I should just like add a check for it, I suppose. But right now it would be undefined behavior in my compiler if I was actually trying, because I'm not having the context, right? And the context that I need is the function context and unwind context, right? So because like if just in case if we are doing something weird there, we're supposed to not do it there. Okay, fine. Let's do this. Function context result type is. Wait, do I ever do the function context? Unit. Yeah, we just need to like never clean up scope. So we should not have the defer statements there. And we should never insert the unwinds in these expressions, right? So we should never like return inside there and stuff. Also, I'm supposed to have a block, I think. Yeah, I also supposed to have the scope and scope context variable there. I mean, I should probably like generate the code with the runtime checks so that. Yeah, but these are the context that we're using when calculating an expression, technically, right? But let me just comment this out. And it's okay, right? I'm just going to calculate, and then we have the actually pure expression over there, right? So value is if value expression is expression. If it's none, then it means that it's the type void. So let's do this. If it's a void constant, I mean f-type unit, then we don't want to even generate it. So we calculate the value here. And then we do this value, and that value is just value. We have type, we have name. It's going to be identifier name. Okay. Yeah, it depends if I like generate something which and does something weird. Well, I mean, technically, if I'm calling a function, right? But I should never call a function, right? When I'm generating the constants. So like that should not happen either. It's expression. What's wrong? Oh, when I print expression, I need to give it the priority, right? Yeah. Minimum priority is 0. This is used for figuring out if we need the parentheses or not around the expression. So now when I create the program, I also need to say the const, and this is going to be a new empty list. Oh, I say convert type. This is a function. We need to convert the type. What? This is value. Value type. This is an expression. No. Convert type type. Type is value type. There we go, and then we convert that. All right, it's going to work. First try, right? Okay, it did work. It did work with this example. And what about this example now? Because we are actually generating the constants. I'm unwrapping the none though. Where am I unwrapping the none? No, now I need to debug this stuff. Help, Corley. So this is me unwrapping this thing. So what is that? What is this code? Program types get unwrap. Hello, rings. Hello, hello. How are you guys doing? You guys do the Ludum there? Or not? No LD for you? It's literally this and no, it's not this unwrap. Hold on. It's when I'm converting the type. The type is not there. I think it's this unwrap, right? Yeah, we have like program types, context program types, unwrap. And then if it's a struct, then we're doing something, right? Like it's literally this code over here. You don't have a team. If you join LD, we'll use Kast. Yeah, I'm not, well, not Kast. I'm making like a mini Kast right now. So I'm going to use that instead. I used Kast for the D2 gem, for the Ludum there. I'm going to test this new thing that I made. The apple catching one, yes. Yes, that one was made with Kast. So I'm working on improving the language, and like to improve it, I make this smaller intermediate language right now. So that's what the mini Kast is. We have the Kast, which is like good, but then before going to and compile it to the like native stuff directly, we go through the intermediate step, which is the mini Kast, and it basically is a standalone programming language too. And yeah, that's it. So Means that I'm having a named type which is not there. That sounds crazy to you? I don't know. Is there like no such like alternate things which are similar to that, but like in art, where imagine before like drawing the actual picture, you first, I don't know, collect the ingredients that you use to create the paint, right? And then you like you craft your own brush and stuff, and only then you do the painting. It's kind of like that, you know? Like I don't know how to make paint. What is paint made from usually? I have no idea. Is it from flowers? You like you like use the mortar and pestle or something on the flowers, and then they like and it becomes like the colored powder or something. You add some water to it, and then you have the thing. Most artists just grab pre-made stuff. Yeah, well, I mean, most game developers use existing game engines, right? Too. Yeah. Most programmers don't make their own programming language. It does make sense to do that. So yeah, we're not trying to like be. We're just like enjoying the process. It's pigment, ground materials, rocks, or chemicals. Then you mix it with a glue. Yeah, see, you know this stuff. Have you ever done this yourself? Though you paint, yeah, nice. Boom, boom. Do you know how to make the paper too from scratch so that you have something to draw on? So if you ever need to survive in the wilderness, you can also entertain yourself by drawing. That's nice. You don't always need paper for that. Well, I mean, yeah, you can draw on rocks on the walls of your cave, I suppose. And you don't need well, I mean, then we can also say that you don't really need paint to draw, right? Because you can like carve the image instead into the rock. Bam, 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 bam. So for some reason I don't have the type. Let's maybe say unwrap or else. Panic. Failed to find type name. So that I have a better error message here. Type info detail. Oh, hold on. It's defails. Wait, what? It's defails. I think I just have a typo somewhere. What is defails? Yes, it's literally just a typo. Details. That makes sense. Because this is just a reference to the type which is supposed to be implemented in the runtime, right? So yeah, so it must match the existing type. Oh wait, but it doesn't work actually. Right, it doesn't work because the details is not going to work still because we still don't have the details. And the reason we don't have the details because I was originally making this for the JavaScript, and when we are right now targeting C instead, and we have this to do. Okay, so this is the type info. I'm generating the information about the type. And well, now that I think about it, right. So I need to create the type info about the certain things. So I need to generate the members, the stride, the size, and alignment of the type. Right? Okay. And then I do have the, do I have the initialize? Yeah, I have initialized type info for structs. So when I have the actual struct, I would be doing this, but this is an actual function, which means that the type information should actually be initialized at runtime. Unless I run this logic. I mean, I do want some information to be done at runtime. But okay, but I can like duplicate this logic and the ones that we know statically. Right, okay. But it means, yeah, like this is for figuring out the layout of the runtime generated types, which we will get into eventually. Okay. Do I have the current completion target though here somewhere? This is the type info, right? Do I have the current completion target? State. Program. Compile. The program. Mini CLI. CLI mini, maybe this one. Let's see what we're doing, right? So if we have the target, which is JavaScript, then we have JavaScript, otherwise we have C. This is my target. Right. Right, but this program, we just say mini compiler compile. So I need to initialize the compiler with actually the target, because the mini compiler should know the compilation target. Hmm. I mean, yeah. This is like the only thing that we need to know about the compilation target while compiling the intermediate representation of the mini cast. The type information. Since I want to like not rely on the targets too much. And I want to have custom targets later too. I would need the custom target to basically specify how to generate the type information that's needed at runtime if we do need it. The reason I need it right now is just because I were doing the allocation of the arrays, which requires knowing the size of the type. Sure, it does make sense. Mini common. Fine, let's do for now. Compilation target is going to be, we're going to have C or JavaScript for now, right? To do allow custom targets. We will figure that out eventually. But current compiler will have the target, which is compilation target. Okay. So we have the target now, and we can query the current target whenever I'm doing certain things, right? So specifically in the type info. I want to like extract this then into the JavaScript specifically, right? Type info.js. This should give me the expression of how to initialize it, right? Wait, what did I get? All of that needs to go over here. Let's do this. So expression to initialize it, right, is going to be match current compiler target, right? And if this is JavaScript, then we're going to say type info.js. But if it's C, then it's going to be type info C, right? This is what we're going to return. So it's the record named name. It should return expression shape, I think. So we're going to return the record fields. There we go. Expression shape. So this would be shape. Expression shape. Type is named name, and span is just a span. Okay, and then we need to implement type info C. You don't think the comparison to an artist making their own brushes makes much sense? Making your own tools in programming is just programming? I don't know. So it's different because making brush is not art? I don't know. Programming is homogeneously layered, where painting is heterogeneously layered. I don't know. Well, but there are different kinds of programming, right? Too, I suppose. I don't know. I mean, making a tool that. Well, I mean, yeah. I don't know. Type info C. That's what we want. Let's try here with uninitialized. I just want to make sure that the thing compiles. But what we want is we want to calculate the stride, the size, and alignment of the type plus the offsets of all the fields. Right? Right. Could find context in scope. Context is the current compiler. Okay. They're not nearly as different as the occupation. I don't know. I feel like when you make your own tools, you need to there's multiple ways to do your own stuff, right? First, you can follow the existing recipe, right? Or you can come up with your own recipe, I guess. And the same is like in programming, where you can make stuff, which is like you don't really need to think about it much. You just need to like write code, right? Like there is writing code, and then there is what's the other thing called, which is the part of programming. Reading code? No, like coming up with the idea, like thinking, you know? Like you don't necessarily need to think always when you're doing programming, right? Mm-hmm. Any part of programming which doesn't involve much thought tends to get automated away eventually. I don't know how that's true. I don't know if that is true. Like we would like everything to be automated, but then like in reality, unable to find type int type info. What do you mean you failed to find the type? Oh wait, am I not generating it now? Hold on, we do have the constants, right? Consts. It is being added, right? And the C is supposed to edit int type info. Can we like it's supposed to be generated? Oh wait, it's not generated because wait, what? Why not? Int type info. We are doing this. Wait, it's failed to find the type in type info, but it's not supposed to be the type. Wait, what? Int type info is the constant. It's not a type. Right? Why am I trying to find the type? Failed to find type. Because this is a type? Wait, why do I have a type which is called int type info? Named type info. Let me see where we're doing this. Right, because the type of this should be the type info. not the int type info. Maybe I'm generating the types incorrectly, and it's only, yeah, it's because in the JavaScript I did not have to do it. Like this is the name. Yeah, the type of it is supposed to be the type info. There we go. Oh, over here, type is name, right? This is not correct. Because the type of this is still the type info of this constant. Right. That was a bug which we did not catch in JavaScript because we did not generate the types. All right, the uninitialized though is not correct here. Yeah, and we were trying to get the current block, and we don't do this because the context is not there. Because uninitialized is actually like creating the variable, and we cannot do that, right? So what is supposed to go into the type info? We're trying to generate the value of this type. Members, stride, size, and alignment. And we're trying to make a pure expression, right? Do I have a list expression? No, we don't. We're not supposed to, right? But I will have to do this as like, yeah, offset or name, type info. So we can have like a reference to the other ones. But I will have to generate the list. I mean, right now I only need the type info for the primitive type, for the integer, right? And for the integer, we just do the size of here, size of here. Alignment is there like an align of in C? C align of, similar to the size of. Wait, since C11 deprecated in C23. Well, just like align of actually, right? Hold on. I might like need to support the dedicated list expression, right? So in C, you can just initialize the lists, right? You can say int star a is list is. You can just do this, right? 1, 2, 3. Incompatible integer to pointer conversion. Wait, what? Is that not how you do the lists? Oh, you need to do that. Wait, and that is different. Wait, so I need not the pointer, but the list. See array versus pointer. Like, what's the difference between those things? When arrays are using expressions, they decay to pointers. In C, array to pointer, decay refers to the automatic conversion of array's name to a pointer to its first element. This decay happens in most contexts when array is used, making the array name behave like pointer. There are a few places when array do not decay to pointers. When using the size of operator, when using address of operator. No, but what about the... Yeah, so it's automatic based on scope, the memory lifetime, right? Like, but is this an array? Well, what is this actually, right? Like, I think they're talking about the fixed size arrays here, right? Declaration, or what am I supposed to... Array declaration. The declaration as the end declares D as an array of n objects, right? So what about the opening and closing bracket? Why can I not find it here? Is that an extension? Oh wait, you have aligned alloc, which is different from alloc, from malloc. Free size. Deallocate previously allocated sized memory. What does that even mean? Deallocate the space previously allocated by malloc, calloc, or realloc. A call to free size that allocates a region of memory synchronizes with a call to any subsequent allocation. Allocates blah 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 blah. This section is incomplete. What's the size used here for? Is it just an assertion? Is it a performance thing? Right. And there is also free aligned size. So you also know the alignment there, right? And then you have the aligned alloc. Okay. No, I mean this makes sense, right? This makes sense to me. And yeah. And this just gives more information about like where like because you can have like dedicated arenas, I guess, for like the certain alignments, and this gives you the access to like where this is actually stored faster, right? So yeah. Yeah. I was literally like asking how to do that previously, and we were like, I'm pretty sure that malloc is just doing the over like assumption of the yeah, like this is suitably aligned for any point object with fundamental alignment, which is wasting memory in theory. And same goes about the alloc A, right? And that's what I was thinking about. Is there alloc A aligned then, which is allocating the stuff on the stack? C allocate. It's in the Linux. Is it not on the CPP reference? Is there allocate aligned? No. The overalignment isn't that bad since the max alignment is only 16 bytes. Yeah, but you can have the under alignment also if you have the type which is supposed to be aligned to more than 16 bytes if you're doing some SIMD stuff, I guess, right? Which would not be possible to do proper, like, which means that you would need to over align if you only had the malloc, right? So you would need to malloc and then like fix your pointer too. But now you have the actual aligned allocation, which is good. You don't think people tend to heap allocate SIMD types? I don't know. I never do this stuff myself manually anyway. I mean, I will have to eventually because I'm making my own language, I guess, but I have not done that before. I don't know, why not? People don't heap allocate in general when they're writing C as much as possible. They do the stack allocations. But I mean, like, isn't SIMD? I mean, no, you are supposed to heap allocate it. Why not? Right? You have a bunch of data that you need to process. How do you allocate it? Like, if it's like user data on the stack, you have to do it on the heap, right? Some styles of idiomatic C actually heap allocate a whole lot. Mostly older C code. I see. All right. Anyway, I was like trying to figure out. We need to construct the constant, which is the type information about like the type, right? Which gives me size, alignment, and stride, and also the member offsets. Which means so like for the member offsets, we need to create the list expression, basically. Right, and then yeah, and then I was like derailed into what's the like can you tell me what is this called in C so that I can look it up when you have the array, or is this like still a fixed sized array Or is this a pointer? Like, I guess we can try this. Type def struct, like list, and this is going to be int list, like this. Can you do that? You can, right? So which means that it's probably a pointer, right? And then you can say const foo, which is like, this is like foo, const foo is dot list is 1 2 3, right? Like this is supposed to work. Right? So how does this work exactly? Like this is, yeah, it's called VLA, but it's not a VLA here. No, no, I think VLA is different. Variable length array is the one that's allocated on the stack, where you give it the size n, which is only known at runtime, right? I think this is the VLA, and this is different. Well, VLA is a way to do the stack allocations, basically, without the allocate. Yeah. So that's just a normal array, right? But this is different from a pointer. And when I have a pointer, then this doesn't compile, right? So my arrays actually must be pointers, must be done in this way. So that is a different thing. So what is this thing called? Because like it's not a pointer, because I cannot initialize it. I can use it as a pointer, right? It's called an array. Okay, array. But like but in the declaration, like on maybe it's a C, oh wait, maybe it's because I'm looking at C89. Maybe that's why, right? I need to look at the latest one, C23. Okay. That is C++, by the way, is it? I'm combining with Clang. Not Clang++, but maybe like, maybe it is. It's compiling with GCC too. Should I try some like some less popular compiler which follows the standard more closely or something? Array types. Let's see, array declaration. There are several variations of array types. Arrays of known constant time, variable length arrays, and arrays of unknown size, right? So that's what we know, what we want. We want to have the array of unknown size. Flexible array member. No. Well, I mean, wait, hold on. Is it? Oh, wait, it must be the last one. Oh, wait, what? Because this is... Oh, wait, what? So this is actually... Compiler may reserve extra padding space here, like it can between struct members. Wait, what? Is this dynamically sized type? This struct data types may end with a flexible array member with no specified size. Typically such structure, like this is different, literally dynamically sized types in C. Okay. So you cannot have a value of this type. You can only have it behind a pointer, right? So does this mean that when we allocate... Okay. Int length. Yeah, and this doesn't work. That makes sense. So it's not actually a pointer. It's literally an array, which is there. When you put it in a struct field, it's a VLA, by the way. Yes. I understand it now. I thought that this was literally the pointer, but this is not a pointer because it's storing the memory directly here. So that's a big difference, right? It is a big difference, and it's in C99. Okay. But you can still have it on the stack, I think, but that like works literally just like the VLAs then, right? So you can say foo f is equal to list is 456, right? So this will allocate initialization of flexible array member is not allowed. No, you cannot do that. Wait, but you can do that with VLAs? Wait, how do you do? Wait, is this allowed though? Why is this allowed? Because the what's the size of foo, right? Why is this not breaking? So am I not allocating on the stack the struct of unknown size?
3 years.
Hello, Nerdcell. 36 months of subbing. Nice. The size of operator on such a struct gives the size of the structure as if the flexible array member was empty. If you stack allocate it, the array is of length 0. So you wait. So you can do it with the variable length arrays, but you cannot do it with this. Like I feel like they could make it be figured out, right? Somehow. But I mean, yeah, I guess that would require some syntax to know what's the size of this list. There can be only a single list in the end of the struct, right? But yeah. But I can do it as a const. I cannot do it as a variable, which is interesting. Also. In C89, people use the zero length array for trailing arrays. That's weird. Why do you use the zero length array for trailing array? Because it like automatically gives you the alignment of this field, is that right? Like if you have the int list of size 0, then like you know that this is properly aligned for an array. Is that the reason? Okay, so what do we want to convert this into then, right? I mean, maybe we have the list expressions. So I cannot have a list expression. Like, I don't know. Like, should I do the pointer here or should I do this stuff? I feel like I should do this stuff then, right? But then how do I initialize it if I do it as a pointer? Can I have a reference to this? Can I have a reference to int? Incompatible pointer types initializing int star with expression of int star 3. Wait, what? Oh, I just need to do that. So that works. But how does this work? Where is this memory located then? So this is my list, right? Which has the data. That's how we represent the lists. Data and length, right? So and over here we say that length is 3, like this, right? So full length unknown temp name foo. 1, 2, 3. Yeah, I think since this is what I list, since that is what lists are, right? Then this is how we generate them. Okay, that's fine. But here's the question, though. How does this work exactly? And what happens if I do this on the stack? Right? What happens if I make this not a constant? But as a local list? Where does this data go? Right? Because this is basically a variable length array. So this is supposed to be allocated on the stack, right? And then I get the reference to it. Is that right? Which I think is okay for me. Is it okay for me? Maybe it is. I just need to be careful that like I understand the semantics of my own language then. Yeah, so like when we so what I want maybe it has the same lifetime as the list itself, so it should be fine. Yeah. No, it should be fine. Right. Unless we return lists from the things, but then they should be like mallocked instead. Yeah, it depends. Like what I'm trying to do here is, so I in order to generate this as a constant, since this works, we will need an expression, which is a list expression, which converts to this thing basically. Same how I'm doing it already for the string literals. We are doing the same stuff actually, but for the string literals, we just say this, which is not stack allocated, but this is an actual constant in C, right? So it's different. If you make a heap allocated version, just remember to malloc the data and not the list itself. Yeah. No, we already have this. The allocation on the heap is already there. But I cannot use it for the constants, right? That's the thing, right? We can allocate list, right? There we go. And now here we are doing the malloc. Yeah, that's something that I'm already doing. Okay, but what this means is that I need some way to have a list expression, right? I need to have some sort of a list expression. What have I done? Why do I have so many things already? Let me just commit something because I did const in C, right? And some other things, but it's okay. Pum, pum, pum. So over here, right? We need to have a new expression, which is actually is it supposed to be a literal in this case? At least literal. It's kind of similar to a record, but a list. And what should be the syntax for it even in minikast? I feel like we will use the initializers like this. It's going to be just like that. Yeah, I think that makes sense. That would be the list if we don't have names of the things. Yeah. But how do I differentiate if we don't have any data? So we have parse expression over here, right? We have parse record, right? Parse record. Oh, but I know the expected type. Oh, but I know the expected type already, right? Because if I don't know the type of this, then we cannot do anything. Okay, which makes sense. Okay. So and then could do a different one if this type is a list. But how do I know if this type is a list? No. How do I know if this type is a list? It means that the list must be the built-in type. I literally made it not a built-in type previously, but the only reason I need it now is because, yeah. Like similar to unwind tokens, I guess, right? Yeah, we have the instantiated token type. Yeah. Fine, we will have lists. List element type is a type. Instantiated list type is type. So because like lists are like the representation of a list depends on the backend, this is the representation in the backend, basically. And this is just so that we know the information about the type. Maybe I should call it wrapper because this is the representation. Yeah, but not here. This should be instead token type wrapper. Let's get rid of the list for now. Just make this changing. Yeah, so unwindable, this should be not wrapper, there should be token type wrapper. Like this. Okay, and then we can work on the on the lists. So it's going to be very similar, right? So we have const type over here. We are going to have the list, which has a wrapper, and the element type, right? Okay. Then we will do the compare types. List. Instead of this is element type. Okay. Okay. So when we want to convert the list, we just convert the representation. When we compile to C, when we want to make sure that everything is defined in the list type, we need to make sure that everything is defined in the representation. When we want to resolve type aliases on the list, element type. And when we do instantiate to type, this also is going to be if instantiation template name is equal to list, because this is dedicated one. We're going to say that the list and element type is template arg number 0 here. list. This is type checking. So for type checking of the lists, list element type is different. On the element types need to be checked. When I print the type, which is a list, say list of elements types, this is type name as identifier, so list element type, we print the representation type. Okay, I think this is it. Kind of. But now we can parse the expression, which is going to be parse record still, but I'm going to say with return here, right? I'm going to say that if type is a list with element types, then I'm going to return parse list list of element type is the root, and it's supposed to give me the parsed expression. Parse list. We have element type option. No, not option. Just type. AST and root. Parsed expression. Like this is going to be the expression. So now I need to have a list expression, right? List expression. And list expression has elements, and that's all. And then type is going to be instantiate type. List with element type. Span is AST span. Okay, that's okay. Now we have the elements. Elements is this. And then we need to iterate over the commas here. Trailing commas and stuff. We say that element is going to be parse expression with the type of the element type, and then elements pushback element. So we have a new expression there. So this is just a list of expressions. Yeah, I think that's nice. So we have a new expression which is going to be a list, which has the list of expressions inside. Do I need to do anything else, or do I just need to transpile it to C now? So, I mean, it is kind of very similar in this case, right? This is basically the compound literal, whatever they call it, right? Yeah, this should have the representation, which is going to be ignored. We just care about the element type here. And I mean, we are reinstantiating the same type, but it's okay. That's could have an optimization though, I guess. The list type, whatever. Why is the error saying wrapper element type is not element type? I did give you the wrapper, right? Can you please pick up this change in my code? I mean, this is a bug, I think, right? Because list. Let's try to recompile from scratch here. Unless I'm misunderstanding something, this probably is just a bug, which is weird. Like, I'm reading the old state of this file, I think. Not sure. So in C, when I calculate a value. Oh, wait. Hold on. But here's the question, right? In C, the evaluation order is undefined in general. Is the evaluation order is undefined for the expression, which is like this? 2. Or is the evaluation order defined for the array literals? C evaluation order for compound literals. Initializers of the sub-objects must occur in the order they appear in the initializer list. Initialization of the sub-objects, members of the struct, must occur in the same order. Is that true? Or is that not it? Yeah, named object at which the compound literal evaluates as static storage duration. If the compound literal occurs at the file scope, and the automatic storage duration if the compound literal occurs at the block scope. The item ends at the end of the enclosing block. Or is anything about the evaluation order here? In particular, the evaluation order need not be the same as the order of the subobject initialization. What is this? What is this document? The order in which any side effects occur within the initialization list expressions is unspecified. In particular, the evaluation order need not be the same as the order of subobject initialization. The extensions to initializers describe this, which is yeah. But at the same time, if we just do the literals there, then it would be perfectly fine. Okay. Did I compile? I did compile. Okay, nice. So I want to have the list expression, right? Which is elements, not the place expression. The regular expression. If I have a list elements, then so we do have compound literal, right? That's what they are called. But compound literal. This is like the field initializer, right? But we want a different compound array literal, right? Maybe I just call it like array literal, right? Which will have the type and elements, which is going to be the expressions, right? Because we don't have names for them. So it's going to be array literal type as convert type elements. We need to calculate every element. Like this. I think that's all that I need to do. And then when I print, when I print the array literal, we print type this indentation. Sure, we just don't say the dot field is equal, right? We just have the expression, which is element, which is just the element. There we go. That's all. Okay, let's try. Wait, actually, no, that's not it, right? That's not it. Because the list, we need to also give it the length, right? Because, yeah. Although that should be done over here, right? So we are creating not array literal, we are saying the compound literal, actually, first. right? Because we need to have the list, which has data and length, right? So we say data is array literal. Let data be this. But the type then of the data is not this, right? This must be the and I need a reference to the array literal, right? Yeah. Because we're trying to get the pointer. But the element type here, right, is what we want. This compound literal has the type, which is this type itself, right? And then we have the fields. So we have the data field. Data field is name is data. Value is data, right? And then we have the length field. And the value is going to be do I just have the raw for the ends? I'm not sure. No, we have identifier. An identifier. No, not identifier. Literal. Literal. This. We have literal int. Literal int, which is a string. So I need to say to string. Elements length. Okay. That works. No. That's the value of the length. The value of this is just the data, which is that. Okay, and then I need to over here to convert the element type, right? So I say element type is match type. It must be a list with element type. List expression is not a list type. Couldn't find elements. Elements. Okay, let's have a simpler example though, because I'm still not generating the the type info, right? Let's have the hello world. Oh, hello MKS, right? This over here we have the 10. This is the Fibonacci and stuff, right? How about I just say this? How about I just say this? Let R, which is a list of integers, and this is going to be, so we're going to say 1, 2, 3, 4, 5. There we go. And this is supposed to compile properly, right? Let's just see. Just see mini hello. It says a list of member infos, doesn't have the fields. Right. So we're trying to figure out the field type, but the object type is this. But yeah, and I am trying to resolve the type aliases here, right? We have a list of member infos. Resolve type aliases, like, because this is the alias to actually the thing. It's a little bit weird here. It's not really an alias, I guess. What am I doing here? Yeah, it still is being a list. So like I need to have the representation type actually here, right? Yeah. That object type is match object type. If it is the unwind token, then we return the wrapper. If we have the list wrapper, then we return the wrapper. I feel like I need to like change my types to like I need to I need to know the type before the alias resolution, the type after alias resolution, and the representation of the type all the time. So like instead of calculating it here, it should already be done here. Okay, it does work now. So what I want is to take a look at the generated C code, right? Yeah, there you go. So we have struct list of ints value, which is this. So that's what I have generated here. A list where the data. Wait, I did not initialize the length field. I forgot to edit, right? Yeah, I only I initialized the data, but not the length. Hello, pink parentheses. My parentheses are blue here and yellow over here and pink over here. We have rainbow parentheses. Right, so the length field is created but never added. Length field, right? And now, since we have the ability to do this, we can generate the type info properly, right? Over here, right? So when we do the type info for C, we have these types. So what we need to do is I need to do similar stuff to what I was doing in the field type, actually. How about I just say type wrapper of object type. Let's have that as a function in common for now. Over here. Let's have that type wrapper is type, which is type, and this should return type. To do should already be stored in type. Right. So we just do this. We resolve the type aliases. We resolve the type aliases. Right. And then if it's the type with the wrapper, then we need the wrapper. Otherwise, we just get the resolved type. Okay, so we do this, and in the type info, we say type is type wrapper of the type. And now we need to actually create the thing. Right, so we're going to match. Well, it's always going to be the expression of the type info, right? So we need to create the record, right? We need to have the expression called record, which has a list of fields. Okay, record fields. So we will need to add the field, right? This is the C runtime. Runtime in C over here, right? We're trying to make this type. Let me copy this over here for reference. Right? So we need to create the type info. So we need to have the stride field, right? Name is stride. I think here the member info on the fields is just strings. Yeah, which I will probably change later, but okay. And then the value is, so, and then the expression is going to be literal int to string stride. Okay, so we will need to calculate the stride here though first, right? Stride field, size and alignment. Right? Well, should this be even the int? No, it's not necessarily the int, because I think I want to generate the raw like size of, maybe in this case. How about this? How about this? Like, I literally just need the one for the native type here, right? Hmm. Stride size alignment. Yeah, because we don't calculate this. We rely on the C compiler to do the correct stride for us. Right. We only do the calculations. Wait, do I wait? I cannot even do the calculation unless I know it at compile time, right? If I'm doing the constant, yeah, I don't know. I feel like I might actually initialize the constants at runtime because of that. So I only need to. Right? Like, because there's actually some like calculation needs to happen. Unless I like hard code the sizes of like the ints. But we don't know the size of an int because that's target dependent technically. Right? Yeah, we cannot know that. Is alignment of the numbers basically the size of the number, right? It's okay. We're just going to do the align of. We want to do the raw parts, right? Let's see. Raw. Get. Okay. Okay. Get property name. This is going to give me the expression. Type. Span. Shape. Type is going to be uint. And shape is raw parts. Parts. Push back raw. So we do a raw name. Opening. Closing. And then I want to convert the type. But this gives me the type. I feel no. I feel like okay. No. This is just the type info, which is like doesn't even know about the C compiler yet, but this should be like specific about the C compiler. Cannot, I don't know how to do this. Hold on. Let's try the beam. Okay, how about this? Stride, size, and alignment is going to be 4. I'm going to have a to-do here, because this is not correct. Like this should be declared in the C. Does it? Oh wait, maybe what this means is that the type info should be a dedicated expression in C. Oh, maybe that's what we want. It's like I'm generating the minicast code here, but I want to generate the target code, the code in the target, to create the type info. Probably. Right? What do you mean? Wait, what is wrong here? This makes no sense. Oh, because it's a let type. Of course, I should not do a let here. Right, like because this is target dependent thing, it means that the type info should be a dedicated expression which we actually like expand later. That makes more sense. Yeah. And then this to do where we can make, right, like we don't have the compilation target anymore here. We should not know about this. Only the backend knows about the type infos. That makes more sense. Literal int is not expression. Right, because it's an expression shape. Right. Because this should have shape is that type is int span. Okay. Okay, if this works, I'm just going to stop here. Like, this obviously is wrong, because not all of the types have stride, size, and alignment, and also I'm not generating the members here. But let's do that in this C, which also means that I don't, like, care about... Expect expression got to data is native null. Wait, what? Oh, because this is a list of t's, right? Okay, so the empty list is now not that, right? Yes, because this is supposed to be an expression. Wait, but in this case, I also want... Okay, now because like I'm trying to parse this as a list and it does not work, but I want to have like the raw. So yeah, maybe I do need to have a different syntax for the struct initialization versus the list initialization because of that. Should it be different syntax? Because in this case, I do want to do that, right? Because this is not an array literal. I mean, I can also like see if it actually has the fields there. If this is a field with a name, then I can fall back automatically. Right? So when I'm parsing a record, I don't parse it as list if it has the field, right? And over here, I would also have to have the type wrapper, right? Type wrapper must be the named name where we get the definition and get the fields. Yep. Or maybe I should do something else after all. Let's do a dedicated syntax. I feel like that's simpler. Mini syntax. Oh, and I can have just the square brackets. Technically. I suppose. I have this thing here. List. Let's see if this actually parses. It might not. But anyway. Yeah, let's not do that. Right? Let's not do that. Let's have a dedicated syntax for the parsing of the list. And we're just going to say that if we see the list, then we parse the list. All right, but we don't have the element type. Now we have the expected type, which is optional because that's now the general parser. But I need to know the type of the list, right? The type of this list cannot be inferred otherwise. Couldn't find element type. Right, so I just say that if let element type is how about say let element type, if this is some list with element type, and return the element type. If it is some other, then we're going to say that expected list maybe say like let me say print type name other is not a list. Let's do IR print, sure. Which means that in this example, we are going to do this syntax instead, right? So let's see if it even parses. Hopefully it should. Right, so this works, it seems. And the test is going to say that contributor properties of undefined block, right? Because it tries to do the block here. Yeah, because it's trying to actually initialize something at runtime. Kind of annoying. That I don't have any extra information here, but we're trying to like do the constant. Am I trying to do the constant here? No. It's just doing the type info generation of the constants, and it fails because the constant expression is having some side effects apparently. Yeah. Okay then. How about we initialize the constants at runtime? Maybe later we will figure out if this is even needed. info type sparse. No, what are we doing? The this here, right? So when we do the constants, we don't say that we have the constants. We do say that the constants are expressions, I guess. But these are going to be like static variables instead. And they are not going to have the values, right? How about this? We are going to say result. No, cast, right? So we have the consts, right? But we also want to have the it should not be a const, right? Because as I tried already previously, mutating const in C. It's undefined behavior, right? I think. You can technically bypass it, though doing so results in undefined behavior, right? And like, because it's putting it into read-only sections or something at the binary, you're not supposed to do that. Anyway. So, but we can do the static variables, right? Static. Statics have types and names. And values are going to be optional expressions. How about that? So these constants are actually going to be the value is going to be none here. We're going to create a static. Then we're going to add the statics instead of the consts, right? But I will want to create a new function, right? Which is initializing the constants. We'll have the thing, so we return unit. Result type. Wait. Right? Because like all of the expressions that we're calculating here, they're going to be calculated in the context of this function, which we are going to call initialize constants. So the unwind, we're supposed to not unwind here though. I think. Panic. Well, it's not panic, right? Because we technically, like, if we want to support any expression there, we should generate this stuff. Maybe we do insert statement to return a void. To do this would mean we didn't finish initializing all consts, right? But we can like check if we are doing that or something. Maybe this should be like sys exit or something. Like something could be generated here that's different, maybe. So the function signature name is identifier is going to be called initialize const. The arguments oh, is this like all of these things that I'm doing? The calling convention is going to be without the context variable though. Wait. I mean, sure, let's have the context there. That's okay. We're going to have the context, but that's the only argument because we don't have the definition anymore. So we have result type void signature. Args is just a single argument with the context. Result type is void. So we create the block. We have the context variable. We calculate. Yeah, but this is the body, right? Okay. So we're going to do that. This block is going to be called init const body. Well, yeah. So the function will be created after we go over the constants. Body. Body is the new block. Result. So we don't calculate the definition body though. We don't. And we clean up, not here. And we don't really return anything. But I don't want to unwind and do this, right? And then we create a new function called initialize consts. Okay, but I do calculate this thing here, and this, when calculated, this should be assigned to this identifier of this static, right? Because we added the statics. Right? But then I'm going to insert statement assign to assignee is going to be identifier name, and value is this value that we have calculated in this function called initConsts, right? And then whenever I'm calling the minicast main, I'm also going to say initConsts before calling the main, right? Like this. Is this going to work? When you have statics, well, I mean, maybe like there is no reason for me to have the const, right? Like because constant is just the modifier, right? They are all static variables technically. Yeah. We don't have consts at all, right? But we can have over here const is a boolean, right? So we can have like const type or just type variable, right? There we go. I think that makes sense. And we say print over here, right? We go for static in statics. So when I print the static, over here I say that if static const then I'm going to print the keyword const. Otherwise, we just print the type. And also, I'm not going to print the equal, and this is only if static x value is some value. Only then I print equals this value, right? There we go. But I need two. St static. Like over here, right? I need to say that const is you go to bed rings. All right, good night. I'm going to end the stream soon too, probably. Const is this is just a boolean, right? False. There we go. Okay, it's compiling, which means that it's going to work. It's really like not that much overhead, right? Can C compiler actually see that I'm initializing these static variables and get rid of that initialization and like calculate it immediately? I don't know. Maybe it's not that easy to figure this out, right? Do, 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 do. RESPC was terminated on line 59 by signal 11. Wait, so I did compile? Wait, hold on. Am I seg faulting? What's signal 11? It's seg fault, of course. Beautiful. Okay. That was just a matter of time. I'm surprised I did not get seg faulted earlier. Okay, let's see the code here. So we are initializing the constants, right? We have type info. Let's see, where is the type info even used, right? Maybe like what am I doing here technically? Initialize const, right? Like the only thing that I'm doing is that I'm initializing the int type info, right? Which is this. So we know that stride is 4, size is 4, alignment is 4 for an int. Is that even true? I mean, hopefully it is, right? So that's the only type info that we have. That's the only constant that we have, which, okay. So then we're trying to create a new vector, which creates a new list. So new list creates a list with data being null, right? And length being 0. Okay, how about we say over here, can I say print created vec, right? And this is like start of main. Let's see if we get to the start of main, right? Yeah, we do get to the start of main. We did create the vec. We did not segfault yet. And this over here, right, should be added 1, right? Added 2, added 3, added 4, added 5, added 6, added 7. Okay, and obviously it all breaks when I push 1, right? So what's happening here? We say if it's equal, then we have the new capacity. So is it allocate the list? Print allocating new memory. I should also deallocate the old memory. Oh, wait, hold on. I know why. I allocated the new buffer, right? But I never said that the vector's buffer is now this new buffer, right? I never said it. Right. Right. So, yeah, because I'm copying to the new thing. Wait, actually, I did not even add one, right? But, yeah, and then I say list index v buffer. Yeah, this over here is the seg faulting because the v buffer is still null, right? I should say that the v buffer is equal to the new buffer, right? This is the list. So we want to say data is new buffer and length is new capacity. That's what we want. And then we also want, since I have done that, I want to free the old one, right? So if not equal, how I want to free the old buffer. Oh, I mean, this should be like the reallocate or something, technically, probably. This looks complicated. Well, I mean, this is implementing the vector from scratch in C, I guess, like the dynamic array. It's yeah, it's not the well, I mean, it is not that difficult, but usually you don't think about these things yourself. I want to free basically, right? Oh, maybe actually, hold on. We just say free list. The buffer. Yeah, that's what we do. And the free list in the C runtime, free list is doing this if it's not null anyway, right? So yeah, there we go. So I'm actually going to free the memory. Free list is a template because when you say free list of t's, expect a reference got list over here, new buffer. All right. Well, I mean, new. Oh wait, hold on. New buffer is the list. It's already allocated, right? New buffer is just the v buffer is just the new buffer. That's all I need to do. I just need to free the old one, and this new one is already here. Okay, there we go. Nice. Print allocating new buffer. Let's just see. It's supposed to do it twice, right? First, so like we created the vec, then we're allocating the new buffer because we're trying to add something to the list, and then after the 4 elements, we are creating the new one. There we go. This works. Okay, I think the next step for me is to move the type info generation into the actual backends. So we need to have like the type info expression. And yeah, it's just not that difficult. Might do it off stream. We'll see. But I want to go rest for now.
few issues, let's say.
Alright, thank you guys for watching. See you next time. Bye.
Let me quickly fix this thing at the top here. If we build right now, it will work because we are not including the texture packer.